What's up guys, I am here to explain lead code question number 886, possible bipartition. So in this question we have different pairs of people who dislike each other, and we want to segregate all these people into two groups such that any of the groups does not have people that dislike each other. So that's our goal in this question, right? So as input we have a vector that has all the pairs of people who dislike each other. For example, in the example one we have person 1 and 2 which dislike each other, and 1 3 and person 2 and person 4. These are the three pairs of people that dislike each other, and also we have number of people n is equal to 4, right? So we want to segregate these people into two groups, right? So how can it be done? By making a group of 1 comma 4, because 1 and 4 do not dislike each other, and the other group 2 comma 3. These two groups can be made, and none of the people in this group dislike each other, right? Same can be seen in the example 2 and example 3. So how can this be done, right? So there is a trick called graph coloring, which means that we need to imagine this question. We need to imagine these people in the form of the vertex of a graph, right? For example, if we create this question, example, which is example number 1, it is 1 comma 2 1 comma 3 and 2 comma 4. So it means that we have an edge in the graph 1 connected to 2, and then we have another edge which is 1 connected to 3, and the third and the last which is 2 connected to 4, right? So these are the three edges of the graph, and we need to color the graph such that no two colors are consecutive and same, right? So this is the approach. So this will be the approach. Let me explain you through a graph that I have made on the whiteboard, right? So this is our graph. This is our example. So in this graph, the person 1 and 4 do not like each other, right? They dislike. So I have made a connection between them. The same case is for 4 and 3, same is for 2 and 3 and 3 and 5, right? So let's start coloring this graph. Okay, um let's color this blue. Okay, hmm, let's make a tick here, right? So now the person 1 dislikes person 4, right? So we need to color this with some other color. Okay, like this, and this is our green. The person 1 is green colored and the person 4 is red colored. So now person 4 is red colored. We need to color this person 3 with green, because 4 and 3 can't be in the same group, so they need to be of different colors, right? So um this is a different color 3. Okay, now 3 has 2 and 5 dislike in the dislike list, right? So we need to color them accordingly, which is red. Okay, so here we go. This is our graph coloring for this graph, and in this case we did not find any pair which can be we did not find any pair which has the same color and are consecutive. So this can be separated, so the people can be segregated into different groups. Okay, so here the groups will be 1 comma 3, and the other group will be 2 4 and 5, right? So this can be the case. But if we had an edge from 4 to 2 as well. Okay, now see, this is an interesting case. Okay, mm, let's erase all our previous colorings. Okay, if we had this edge as well, now let's try to color these edges. Okay, so one will be colored green. Okay, which means we need to color 4 red. Oopsie. Which means we need to color 2 green, and color 3 also we need to color 3 as green. but now you see 3 is adjacent to 2, so we can't green color 3, right? But it is also adjacent to cross red color, so this is a problem, which means that we can't segregate these people into two groups, right? So that's what we are going to do in this question. Okay, but how we are going to do this? Let's imagine we have this graph. Okay, um, um just a minute. Alt. Okay, we have this as our graph, right? These are all different nodes than these. Okay, now we start from this point, right? And we color this like this and this, and we then color as tick this. Oh, okay, just a minute. uh, yep, this is good. Let's take an eraser. Okay, no, like, let's start coloring this whole graph. We start with one, it is colored, then cross, colored, cross. No, I am making some silly mistakes here, just a minute. This will take, this will cross, and this will be tick, right? We colored this successfully without any problem. Now let's start with this also. Tick, cross, tick, tick, cross, and then cross. See, we didn't have any problem with this, so in the entire graph we didn't have any problem, any clash between the ticks and the crosses, right? So this is what we are going to do. But how we will do this? This can be done using either DFS or BFS, and that can be done using a queue. Okay, so what we can do is we can store this one, right? We can start from this. We will color this at tick, right? We will color this with a tick, and then we will check all the other nodes which are not colored, right? Which are not colored, either tick or cross. The 4 is there, right? We will color this 4 as cross. Next we have 3. We will color this opposite, and 2 opposite, 5th opposite. Same for this. This can be done using BFS very easily. So let's jump right into the code, right? So initially we need to make the graph, right? So that can be made using an unordered map. um, right, this is a unordered map. um, Now for each pair we need to connect them. Mm, Graph D0. Okay, and the same with the other. Cool, we have completed our graph. Now let's jump into the BFS. Okay, also I want, no, let's start with the one indexing for the name of the nodes. There is no issue in that. um, then we will iterate through each and every node is equal to n. Let's declare a queue for the BFS. Okay, also we need to declare a vector for storing the color of all the nodes. Okay, so here 0 means the node is not colored, right? One means tick, and -1 means cross. This can be a good nomenclature for our BFS algorithm. Okay. First, we will check if the node is already colored. Then we don't need to do BFS on that again, right? So if it is already colored, right? So if color of I is not equal to 0, right? We will simply continue and start for the next node, right? But if so, we need to give some color, some starting color to the node. So we can give a color as 1. Okay. mm, Also, let's push this node into our queue. Okay, while queue dot size. So now our BFS has started. Breadth first search. um okay. Queue dot front. This is the front node, right? This is the topmost node. Let's pop it. Okay. Now we will check for all the nodes that surround that node. So if if the color of that child is not initialized, right? If the color is 0, which means if color is 0, we will simply color that with we will then simply color that child with the opposite color, with the negative of the color of the node. So is equal to -1 color of node, and then push that node for further BFS. Oops. Cool. But if color of child is equal to color of node, if the color of child is equal to color of the node, which means that we have two nodes together consecutively having the same color. So in that case it will be impossible to segregate them into two groups, as we have already seen in our graph, right? So then we will simply return 0. Okay. Return false means. But if our BFS successfully gets completed, which means that all the nodes are colored properly and there is no issue, in that case we will simply return 2, which means that we can segregate, which which means that the people can be split between two groups. So let's run this code. Just a minute. Graph node. There must be some silly issue, I am pretty sure. Oh yeah, yeah, because we are using one indexing, right? So we need to do n+1 here. Yeah, silly mistakes happen sometimes, but else our code is fully working. um let's try to submit this code because we are within all our constants. The time complexity is big O of n, right? The time complexity is linear, so that's not an issue here. Is it linear for each node we are coloring? Yes. Time complexity is linear. Space complexity is also linear because we are using a one-dimensional vector. So space complexity is also linear. All the other constants do not require any long or unsigned long integer type. So we are good to submit our code. Let's try. I am pretty sure there are no issues with the code. So here you go. As I said, there are no issues with the code. So I hope you like the approach. I hope you like my approach. This can also be done using DFS instead of BFS. We just use a stack, right? That can also be a way, right? So I just showed you BFS. By DFS, it can also be done. So I hope you like this algorithm. So thank. See you around with my next solution. Bye.